So welcome to episode 4 of our series, the Wi-Fi Scanner network series. So in this we are going to modify the hardware setup and include battery. We'll shortly show you the hardware changes that I have done. Reuse the existing scan code, like the base is episode 3. So whatever we have built in episode 3, we'll use that code as a base, and then on top of it we'll add additional things. So first thing that we're going to change is the hardware, where we'll include the battery, and we are going to use 18650 battery. We'll modify the software and add the BLE scan. So far we were doing a network Wi-Fi scanning. Now we'll add a code to do a BLE scan. So basically the Bluetooth scan. It will scan all the Bluetooth device and display on the TFT screen, and see any hardware troubleshooting that we need to do while making this project. So before further delay, let's move to the hardware and see the battery setup. In this episode, we are trying to replace, or in fact, we are trying to update this with a battery. We don't need to connect to the USB. Once the software is uploaded, we can run it using a battery, 3.7 volt 18650 battery. And if you see, I have just removed this power VCC and ground from the TFT, from the ESP32. So we'll be shortly connecting this with the external source, and will not be using any USB like power. So it will be through a battery, and which can be recharged. So for this we need some additional things which so far we have not yet used. So first thing is a battery charging module and the battery itself. So if you see, I am using this battery charging module. This is TP456. So it's a TP4056 module and a 18650 battery connected with an external connector. So this will be shortly, I have split into this to two part. One is a charging module. So this will charge this battery, and we will connect here with the micro USB port. So this will allow us to charge this battery, and will power it using a battery. So for that we are using a 5 volt boost module. So this is a 5 volt boost module. So this is having a USB connector. You can buy without this USB connector also. So I was having this, so I am using this one. And the back end, if you see, I have connected plus and minus, which will be connecting to the ESP32 and TFT display shortly. And this is the input from the battery. So where we'll be connecting this using this. So I will show the detailed circuit in the screen. It's simple, not very complicated. So if you need any help in detail, you can comment in the video, and I will explain that. So but it's a straightforward. So one is a TP module, the charging module. Instead of this 4056, you can use 5100 also. Both are one is more advanced one, but this is, I think we need only one battery, so this is sufficient to charge, and it has a battery protection also. And this is the USB boost, USB 5 volt. So this will convert the 3.7 volt from the battery to 5 volt, and this 5 volt will be passing it to the ESP32. So this is how it is connected, and there is a switch here to stop charging, or charging, or stop. If you want to use just a battery, you can just stop the charging module if it is connected to the power. And this is how it is. So let me connect and show. Since if you see, this LED light is going because it's showing me the 5 volt output from this battery. So we can show, just let me show you the multimeter reading. So right now I have not connected to the external source. It's just a battery. The external source, this micro USB, is still not connected. So we'll connect and shortly and show you that also. But without that, like assuming that you are connecting this with the battery. So here, if I just quickly show you the measurement. So you can see 5.3, this with zero load. So once we have the TFT connected, so it will come around to 5.1 volt. And now if I connect back the battery, So now I am connecting this micro USB, powering it with micro USB, assuming that will charge my battery. So this is a micro USB connected, and this I am connecting to the external USB power supply. I'm using the laptop power supply, but it is you can use any phone chargers also. So now if you see, this TP4056 module is powered with the external, and this will charge this battery, and this is 18650 battery. And if we want to stop charging, you can just switch off this. So the blue light will indicate that it's now powered with the battery only. And this, if I just switched on, so this is, I have bypassed this. If you notice this, the output of this module, charging module, is bypassed through a switch. So if we want to stop the charging, we can just switch off, or instead of removing the micro USB cable. So this is here, and this I have connected to this output of this charging module to the battery, and also in parallel the battery output with this boost module. So this is how it's complete setup. And once we are connected, so it will power it. This will connect this output 5 volt 5 volt constant output with the TF ESP32. So this is how. So there was one issue while connecting to the ground of ESP32. So if you are trying to use this module and connecting using the power battery, make sure that your ground is properly connected. So the issue that I was facing was that the ground wire, one of the ground in ESP32 is either not properly connected to the other ground, so which was creating a problem. So if you notice that there is two ground pin, one is next to 5 volt, this is a 5 volt, then there is a ground pin here, and the another ground pin is on over here. So the one next to the 5 volt was creating a problem. So it was it basically, there may be some defect in this board, or maybe it's the design, but this ground and the other ground is not connected. So there was some issue. So if you face that external source not powering up, there may be a chance that the ground is having an issue, ground pin is having issue. So once you resolve that, it should solve, it should power up. Now I will, so this is the setup. Now I will connect this power and the external power with the ESP32 as well as the TFT, and show you the output. So we'll just pause the video for some time and connect, and then come back. So I have now connected this with the external source, and you can see this output is there. It's the same out. There is no change so far in the code. It's just that I have added the external power source. So this is the one which is connecting to the TFT, and this wire, the white one, is the power source from the 5 volt over here, and this ground pin of TFT and the ground pin this of the ESP32. So all both, like 5 volt plus ground to TFT and 5 volt plus ground to ESP32, powered through this 5 volt boost supply. So this boost module will convert this 3.7 volt from this battery. In using this boost module, it will convert to 5 volt, and then 5 volt we are supplying it to TFT. So this is the complete setup, and right now it is the charger is also connected. So I will just remove this. So now it's all through battery, and it's without the charging. The charging is not on right now. So all this is now powered with the battery. So the next step will be in this module episode, we are just trying to from the software side, we'll enhance few code and make it a little more polished. So far till now there is no change made from episode 3 to this episode in terms of software. So shortly we'll look into the screen on this total that block diagram, the schematic of this setup, and I will just put this all into a box so that it is easy to use it, and it's not doesn't look so cluttered, the wires. So now I have put everything into this box, and so far I have not sticked or screwed this board. Once the final version is complete, I will add this as the on the top of this display on the top, and this USB connector, like micro USB, will be pointing out over here, so that it will be at the bottom of over here, so that it is easy to charge. And this indicator will pass out on the top of the screen, and there is one the switch that was there that will also will move it on top of the cover, and along with this TFT screen. So once that final version is there, it I will complete that installation and the wiring in that box. So till that time I will keep it as it is open, and so that we can, if there is any change required, we can do it. So now we'll move shortly to the screen and show you the software changes, also the schematic diagram of this setup, the battery power device. So if you see now, it's completely totally free from any USB, only require USB if we need to upload the code. So while uploading the code, we need to make sure that the power supply external source is removed. So I have made it removable. So we'll detach this power supply and then upload, connect the micro USB with the laptop, and then upload the updated code. So once that is done, we need to remove it, connect back this to the external source, power source, and we are all done. So now that we have seen the battery setup and it's running, we'll now move into the code and see what how we can enhance our Wi-Fi scanning code and add the BLE scan option. So we'll try to keep the same architecture, structure, and everything as similar, and we'll add an enhancement to that. So what we will do, will not touch the existing method or any other that we have built for the Wi-Fi scanning, because that's running fine. So we'll not touch anything. We'll add additional methods for BLE scan. So the code is same, so the structure, everything is same. We are using the same base as in episode 3, that is the ESP32 Wi-Fi Scanner and .ino, config.h, display manager.cpp, display manager.h, and theme.h. So we are not going to make any change in the theme.h. In the display manager, what we are going to add is the support for the BLE scan. So what we are going to do is we'll add the method for BLE, clearing the BLE's area, drawing the header, the BLE header, because this will be different than the Wi-Fi header. So if you see, the draw header is this, the Wi-Fi header. So for the BLE, we have added draw BLE header. We are not making any change to the existing method. We are just adding additional things so that the existing code doesn't get disturbed. And then drawing the BLE device detail, so that method. So this, and also the displaying the BLE count, the device count on the of the BLE scanning. So we'll define all this in the display manager, and here you will see the method that I have added. So it's totally separate from the existing one. So we are not making any changes to the old methods, and we are just adding, like for the BLE net manager, clearing the BLE area. So we are using this. It is similar to the existing one only, just that we are, for the BLE, we have created the separate methods and we'll call them separately. Similarly for BLE header, so display header is, the column numbers are same. Color schemes also we are trying to use the same one. So everything is same. That's text color and BG color, it's as defined in the theme. And then draw the actual BLE device. This is a header row. Similarly, displaying the BLE device detail. So this method is also same as that the Wi-Fi scan method, displaying the Wi-Fi scan. So if you notice that this part, based on the color RSSI strength, we are changing the color of the text. Similarly, if we are limiting the total number of the characters that need to be displayed. For BLE, we have kept it at 15 character, and if there is no name displayed, we are displaying as unknown. So some of the BLE device may not expose the name, so if it is empty, we are displaying as unknown. Text colors are same as I have used in the Wi-Fi scan method, and like displaying the Wi-Fi scan results. Similarly, the footer part, so it's all same. Device, it will display the device count, total BLE device that is scanned successfully, and it will display in the footer. So there is also the format, color, everything is same. If you notice the old methods that I have used, it's all same, and the structure is also similar. So like this is the draw network, that is the Wi-Fi scan result it will draw, like update in the TFT screen. So this same structure I have used over here. So this is exactly same. Next change that I have done in the config.h, added one constant. So this is like total BLE device that we want to display. So far till now we have seen that we are able to successfully display 9 devices without any issue. So similarly for BLE devices also we are using 9. So this will be the value that we will be using in the actual INO file. Here also in the INO file, few things that for the BLE support we need to include is this include file, the BLE device.h, BLE utils.h, and BLE scan.h, and the BLE advertised device.h. So all these 4 files we need to include for the adding a support for BLE device. Also we have included a variable BLE scan, and here we are calling the in the setup we are calling the BLE scan. So if you see here, so we are getting the scan result and storing the total device result in this variable, and then setting up the details. So here we are, so this get scan will be showing you, and then this is the initial scan, the initialization part. Similarly in the loop we have added the scan BLE scan. So this is the scan network, is our existing method which scans the Wi-Fi. This scan BLE will now scan the Bluetooth devices. So this is why we are defined this as a separate method. And if you go down at the bottom, added this support scan BLE. So this will now scan the BLE devices and store it and display. So what it will do, it will scan the result device and store the total count in the device count. And then right now for debug we are displaying it in a serial monitor, but this will be actually be displayed in the TFT also. So this method clear BLE area will clear the, if there is any existing data, it will clear that area and then draw a header. So far we have not changed anything in the header format, anything, it's all same. We will shortly change that also, so that it displays based on the whether it's a Wi-Fi scan result or whether it's a BLE scan result. So that make changes we'll do as the second part of this video. In the first part in the software we are just making sure that our BLE scan result is successful and it displays correctly. So now here it's the max BLE device, that is 9 that we have given. It will pick as 9 value and then display the 9 devices. So here is the actual device display. It will count through the loop and display this device into the like it is extracting all the device details, all the details from the scan result, and it's calling this BLE device display.draw BLE device, and it will display in the TFT screen. So this method will be called alternatively. So if you go to the loop, if you see, so first it will calls the BLE the network scan, then it will do the BLE scan, and within that interval every 10 seconds. So it's alternatively, first it displays the Wi-Fi scan and then the BLE scan. So once we compile, and this I have added as a device on the screen also as a display. So let me connect the device and then show you. It's right now disconnected. So I have connected the code. This code I have published and it's uploaded into the ESP32. So now if you see the scan result initials, this is the old code. So start BLE scan, and it will, after that BLE scan, it will scan the device. And so this I have displayed as a debug information on the display serial monitor, but this same is also getting displayed on the ESP32. So we'll switch the camera and show you the result. So this will scan alternatively. First it will, it's a network scan, I am not showing anything on the screen, but the BLE scan I am showing you on the screen. So it will scan the result and show over here. So many devices are shown as unknown because the name is not exposed, but some of them, like here Geo set-top box, if you see, this is displayed. So there are few other devices. Right now it is not scanning, but if it is there, it will scan and show the result. So we'll switch the camera and show you the output on the screen. So if you can see, this is right now the battery is disconnected because I have uploaded the code. And if you see this Wi-Fi scan, so right now it is showing the Wi-Fi scan result, but yeah, now if you see the BLE device result, so it's exactly same, almost similar. But if you notice that the header, it is still showing Wi-Fi scanner. So what we'll do in the next shortly is make some changes into the UI, display UI, and we'll make so that it displays the correct uh, information in the header, like whether it's a BLE device list or whether it's a Wi-Fi device list, so that it will display accordingly. So we'll make a change and then come back again into this screen. You have seen the BLE scan result on the serial monitor and also on the actual device. So the next step was to make some changing into the header and the display, so that both the screen display is consistent. So like whether it is switching to Wi-Fi or switching to BLE scan, so that what we have done is made some changes to the existing as well as to the new code. So first change is in the header. So if you remember, we have a display header, the column header, as well as a normal draw header which shows the string. So here we are showing the network scanner. We change the label from Wi-Fi scanner to network scanner, and in this method we are passing as a mode. So what this mode will do is that we are passing whether it's a Wi-Fi scan or either BLE scan. So depending on that, it will append at the left side, sorry, the right side. Along with digital lab, I am adding the mode. So whether it's a Wi-Fi or it's a BLE scan result, so that it will show. And this mode, when we are calling this draw header, we are passing that mode just before the scan. So that I will show you from where I am passing. So this one change I have done, and also in the column header, not for this column header, this header was all good. In the BLE, in the earlier version of the BLE scan, the column header was not aligned with the Wi-Fi column header. So what I did is I just replaced the earlier code, this I had been using, with the new code, like for the BLE header, which was adding one additional row. The header was displaying, column header was displaying in the third row, but we want to make it consistent. So I use the same code as for the Wi-Fi column header, Wi-Fi scan column header, and just replaced, instead of in that we have more than 2 columns, but here we have only 2 columns. So BLE device as one of the column, we have aligned the text left aligned, and then displayed the BLE device as the column header, and the next column was the RSSI. So there in this BLE scan we have only 2 columns. So rest is not required from the when compared to the Wi-Fi scan. So in this, while using this BLE device and RSI, this code, there was some overlap using list Y. So there was some overlap, and we were displaying in the third row. So to make it clear and clean, I use the same code and just replace the header, different header, column header. So these 2 changes done, and rest there is no change required in this to make it seamless, both the UI. And to match that, in the Wi-Fi scanner, the way I am calling is, if you go to first, let's network scanner. So here if you see, so here first we are calling the like clear network area. So this is same as earlier. So instead of earlier I was displaying header only once, but now we are displaying the header every time, re-displaying the column header, because we are adding this mode. So we are passing this Wi-Fi text as a mode parameter into a draw header, and then we are also redrawing the column header. So this draw header and column header we are drawing every time, like in the scan networks, which will scan the Wi-Fi network, and also scan BLE. We are displaying this draw header with the BLE as the parameter, and then the second method, that is draw BLE header. So this is a column header for the BLE scan. So these two we are calling again. So for each scan we are redrawing this header, column header and the main header. The rest the code is same, which we have seen just now. The UI display will look seamless. So I'll switch the camera and show you the output and how it looks like. So I am uploading the code and then we'll switch to the other camera and see the output. So now if you see the BLE scanner and the network scanner, so the header, if you see, I have changed to see network scanner, and next to it it's the BLE, which means it shows the BLE device scan result of BLE scan result, and this is showing all the devices. So two columns, BLE device and RSSI. Now in the network scanner, Wi-Fi scanner, we see the column header as Wi-Fi. So we just switched now. Just let's wait. I will show you again when it comes back. So if you see the Wi-Fi is written, so this is a result of Wi-Fi scan, and some networks in green color, which means it's stronger in strength. So the less the negative number is more strong. So this interval, scan interval, is right now 10 seconds. We can increase it if required. That's also given the config value. So this is how it switches to and fro, and the UI slightly more consistent between the Wi-Fi scan and the BLE scan. Now as a next enhancement, we'll try to like earlier the plan was to include in episode 4 the sorting and displaying a result accordingly, so which we didn't include in this episode 4. Instead we went ahead and added the battery and the BLE scan. So earlier plan was not to include BLE scan in this episode, but I included the BLE scan also in this. So to keep in mind before we end this video, and there are a few things that you need to keep in mind. First thing is that for this episode you will be definitely needing soldering iron, so that you can solder few components or modules, because it is not just plug and play. You need to solder the wires, so which we have seen earlier in the start of the video. So the two modules, TP4056 and the charging module, and the 5-volt boost supply module. So that two modules we need to connect along with the 18650 battery. So for this episode, there is a prerequisite is that you should be aware of how to solder, do a basic soldering, and connect these two modules with this ESP32 and TFT scanner. So this minor slight enhancement to your skills is required, and additional modules are required so that you can include it in the battery. So if you don't want to include the battery part and you just want to enhance use the BLE scanner, that is also possible. So your earlier code, right now if you see, this is the battery is disconnected and it is connected to the USB cable through the laptop, because I use that right now to upload the code. So you can use this and just complete that BLE scan part also. That does only the software changes on top of the episode 3 code, or you can do the both hardware change also as well as software change, or the other way around. You just want to make the hardware change, you can do that hardware change only, like including the battery part, and don't want to add the BLE scanner. So this is all in the episode 4. And one issue, like if you are doing this again, like in episode 3 we had the issue with the pin GPIO pin 02, which we have to move to GPIO pin 27. In this we had the issue with the ground pin. So the ground pin next to this 5-volt was having an issue. So we were not able to get the display if the ground pin is the next to the 5-volt is used. So that was easy to use because I was using the 2-pin connector, but since that ground pin was not I just not properly connected to the internal circuit, So I had to use the other ground pin which was earlier I was using, and for which using which it was working fine. So I switched to the old ground pin. So in that case it started working. So in your case also, if you are using ESP2 module, ESP32 module, there may be a chance that one of the ground pin is not properly connected to the other ground pin. So just try to change the ground pin if you don't see a display. There can be one. So I was having a blank display. So that issue can be because of that incorrect ground pin, or ground pin not properly connected. So you need to make sure that ground pin of the source is connected to TFT ground and the ESP32 ground. So all the three grounds should be interconnected. So if there is any disconnect, you will not see the display. So in this episode, we are finally concluding, and the key takeaway is that you need some hands-on on soldering. So you will definitely need a soldering iron, soldering wire, paste, along with this modules, additional modules, a battery, a charging module, and the boost connect 5-volt boost. So this is all in this episode. We'll see you in next episode, that is episode 5. So we'll try to see what additional we can do. One thing that I am planning to include in the next module is adding the SD card reader. So what we'll do, or the touch, or either of them I will try to include, or if possible both, or any at least one of them, so that you can store the scan result, both the BLE scan and the Wi-Fi scan, into the SD card, and use it for your later use. You can just log through, display in the outside the website using the web server. So that is the possibility. And also there is along with these two enhancements, we can see if we can add anything else on that. But definitely the next episode will try to keep it little simple, like will not add any additional modules along with this. Only will be trying to use whatever we have this at this moment. So, and with the possibility of detaching the battery. So right now, since I have detached, you can detach the battery and use it. Or if you have not, if you are not planning to implement the battery mode, so you can just directly use the USB to complete your project. Thank you for watching this video. And if you have any issues or any doubt or any clarification, just update in the comments. I will try to answer as soon as possible.